Hello, this is Seth Davis, this is Lab 5. The objective of this experiment was to observe the motion of shooting a basketball into a hoop and to calculate the drag force necessary to make the ball go into the hoop. My result is I found the constant drag force necessary to make the ball go into the hoop to be 3.32. In this lab, I will identify physics principles used to model this simulation. I will set the initial data, show my initialization, and I will run the model and check my answer. The principles I used in this lab were Newton's second law, which states that final velocity equals initial velocity plus the total net force acting on the system over the mass times the change in time. The other principle I used was drag force, which force of drag equals negative b, which is the force constant, times velocity squared. Here's the video I recorded and tracked. As you can see, I made left the positive direction for my graph. It's going up in the positive direction, not negative. Here are my initialized conditions. I had the mass of the ball is 0.623 kilograms. I had the position of the ball, which is negative 0.42, and the ball's velocity, which I estimated through my graph to be this. I have a gravitational constant and my b, which I calculated through trial and error. Another thing I had to do was implement my physics principles, which I have here. The weight force is equal to negative ball dot m times gravitational constant times j hat vector. The force of drag is equal to negative ball times the ball's velocity squared, and F net equals the weight force plus the force of drag. Here I implemented Newton's second law, and here I used that to predict the new position of the ball and as I advance the clock. I first ran my model without the drag force, and this is the result. As you can see, the model goes way over the observed, showing that there's a lot of drag force necessary to make the ball stay down and go in the basket. Through trial and errors, I was able to find a drag force constant b that was able to make my graph closely match my observed results. Conclusion: I concluded that the drag force constant was 0.32, and my graph might have been a little bit off, but that could be explained by wind and other external elements. Thank you, and goodbye, physics labs forever.